Hello, in this lecture we're going to work some test type problems that are short enough to fit in multiple choice type questions. First we have a company must repay the bank a single payment of $21,000 cash in 2 years for a loan it entered into. The loan is at 10% interest compounded annually. The present value factor for 2 years at 10% is 0.8264. The present value of the loan is what? So we have the loan that we're going to pay back. What would be the present value basically after 2 years considering a 10% interest rate? Now the easiest way to do this would basically be to look at a table in order to find the rate here, the present value factor, which they gave us. So we don't need the table right now, so they made it pretty straightforward in the multiple choice question. We're just going to take that 21,000, and since it's 2 years time, and if we looked up in the table and they said that it was a 2 years at 10%, and they gave us the factor of 0.8264, then I'm going to go ahead and add decimals. Go to the Home tab, Numbers, add 4 decimals. Going to underline Home tab, Font, underline. Then we're just going to say this equals the 21,000 times the factor that was given to us. And so therefore, the present value, today's value of the is 17,354 if we were to pay back the loan of 21,000 after 2 years at 10%. Next one says a company borrowed cash from the bank by signing a 7-year 8% installment note. The present value of an annuity factor at 8% for 7 years is 5.7064. Each annual payment is $42,255 and 69 cents. The present value of the note is what? So we have kind of the opposite here now. Now we have basically an annuity. As long as the annuity is constant, then once again, the easiest way to do that is to look at the annuity table and figure out what the value would be. And they gave us that factor. Again, assuming the 8%, 7 years, we're going to have the 5.2065. So now we have constant payments of 42,255.69. I'm going to highlight all of these and go to the Home tab, Numbers, add the pennies onto that. And then we're just going to multiply that times the 5.2064. That's the amount we would find in an annuity table based on 7 years. If we found the table would have 7 years and then 8%, and that would be at that section. We're going to go to the Home tab. We're going to go Numbers. We're going to add the decimals so we can see all those decimals. Going to go to the Home tab, Font, underline that. And then we'll just multiply that out, 42,255.69 times 5.2064, and we get a number too large for the cell, which happens to be 220,000 and 2 cents. Next one says a company purchased equipment and signed a 6-year installment loan at 10% annual interest. The annual payments equal $5,200. The present value of an annuity factor for 6 years at 10% is 4.3550. The present value of the loan is what? So once again, we have this even payments of 5,200. Easiest way to figure that out is to look at an annuity table and look at the columns and rows intersecting between 6 years and 10%. And we're going to get a number greater than 1 because it's going to be bigger because it's an annuity payment. And we're going to have an even number of these payments at 5,200 for 6 years. So again, you would think you'd multiply times 6, but it's going to be less than 6. The factor, because of course of the fact that there's 10% of interest or value in here. So we're going to take the 5,200 multiplied times the factor. They just gave us the factor from the table being 4.355. I'm going to go into the Home tab, Numbers, add decimals like that. We're going to go into the Home tab, Font, underline, multiply this out. We're going to say the 5,200 times the 4.355 gives us this 22,646. And again, the instinct would be, if there was no interest factor here, would be just to take this and say, well, if there's going to be 6 years and there's 6 payments, it should be 5,002 times 6. But that's not the present value because of the fact of this time value money or this rate that we're going to have for the present value, which is going to be, of course, less than the actual dollar amount. Next one says assets of 32,612,000, total liabilities of 19,462,000, and total equity of 13,150,000. The debt to equity ratio for the period is what? So the debt to equity ratio is pretty easy to calculate. It actually tells you exactly what it is. It's debt over equity. It's a ratio. It's the debt compared to the equity. So we're going to say the debt then equals the liabilities of 19462,000. And the equity is going to be this 13,150,000. And if we divide those out, I'm going to underline home tab, font underline, and we're going to compare the debt, the 19,462 over divided by ratio, the equity 13,150, and we come up not to 1 because we're going to go to the home tab, numbers, add some decimals. So notice the debt is greater than the equity. Remember what the equity represents. Assets minus liabilities equals equity. It's kind of like the book value of the company, and therefore the debt is greater than the equity in the company. Now, note that we have 3 zeros here, and if you wanted to round this, since we're talking about millions of dollars, and it's probably okay to round it, and it's even in terms of thousands. So if you just plug in this into a calculator quickly, it would be fine to say 19,462 over 13150, dividing each side by the 1,000, in this case, dropping those zeros off because they're just zeros, and we take the 19,462 divided by the 13,150 and add decimals, and we would then get the same number.